Last time we had finished section 7.4 to the point of talking about percents, and we're going to talk about interest today. Just as a reminder, we had come up with an equation, talked about it briefly, a couple of equations for interest. Talked about this simple interest equation, and then we talked about this compound interest equation. Typically, the context of the problems are pretty obvious as to which ones that you will be working with. If you're unsure, we can talk about those as those occasions arise. But the general rule of thumb is simple interest is something that is done not in a real financial institution. Financial institutions typically do not do simple interest. And then if they do simple interest, it actually says simple interest in the problem. So there's really nothing left to the question. And almost always when you see the compound interest, it will say the phrase compounded, and it will tell you how often. Now, a few things to be aware of in these particular problems is what these letters stand for. Some of these I know you've seen before. I'll write these in here. P stands for the principal. The principal, I have no idea if I spelled that right, principal. Every time I get to this word, I never know. Is it A-L or L-E at this point? Is it L-E? Excellent. Well, I guessed right today. The principal is the amount of the original investment or the amount of the original loan. It's just how much you've either borrowed or you've put in the amount to save, okay? R is the interest rate as a number. For example, if you had 7%, R would be 0.07. You do not put it in as 7. It's 0.07. Change it to a number. T is the time, and it's important to remember that the time in these problems is always calculated in years. So if they give you something where the time is not in years, the first thing you have to do is figure out, well, how many years does that mean? So if they talk about something being 36 months, that would be a T equals 3 for 3 years. So don't let that sort of catch you off guard. And then the last letter you're seeing, so all of those are letters in both formulas. The last letter is only in the second formula. That's N. N is the number of compoundings per year. So what does that mean? Well, if you have something that says it's compounded monthly, you figure out how many months are in a year, and the answer would be 12, so N would be 12. If it said compounded quarterly, how many quarters are there within a year? 4. That's what we mean by the word quarter, right? 4 quarters in $1 and so forth, 4 quarters in a basketball game or something. If it said compounded annually, that's 1. Semi-annually, that's 2. You see those for sales, right? Semi-annual sales. Occasionally you'll see, or you could see something compounded daily. 365. Yeah, we're going to round to the 365. We're not going to worry about that extra quarter day business. Yeah, I know. You could do compounded weekly. 52. I'm checking on your remembrance of these details about the calendar. 52 weeks in a year. Occasionally you'll see something that'll say something like compounded biweekly. Do you know what biweekly means? It means every other week, every 2 weeks. So that would be 26. Sometimes people will get paid biweekly. My husband gets paid biweekly. It's awesome.
Okay, I have a question.
Yes.
So let's say it's like for like 6 months, not for a year.
Mm-hmm.
So would T equal half?
Yes.
And then would N, like if it was like monthly, would N equal 6 or would
Yes.
N equal 12?
N would be the number of compoundings in a year, so it would still be N equal to 12. Yeah, it would. And the formula would take care of the fact that that would still only happen actually 6 times within your time frame.
Okay.
So the formula itself would take care of that part of it. Mm-hmm. Okay, I put a note on here that this formula looks different than the one shown in your book. Your book does something a little bit differently. I want to use this formula because this is the one that's done in almost all books. The one in your book is simply not the one that's commonly used. So if you were teaching out of any other book where you were talking about interest, these are the formulas you're going to see, not what your book's presenting. I've never seen those get in a book the way your book shows them, okay? So just don't use the book formulas because they're going to look different. All right, we're going to do an example. A company is expanding its line to include more products. To do so, it borrows $320,000 at 13.5% annual simple interest for a period of 18 months. How much interest must the company pay? So the first thing you have to figure out is which formula it's asking you to use. And which one is it asking you to use? How do you know? Because it says so. So simple interest, so that's the one we're going to use. All right, so the simple interest formula is over here. There's like 2 versions of it. It doesn't matter which one you use. I'll just use the first one this time. Okay, now notice I didn't actually write it down over here. Maybe I should have. A in these problems is the amount after T years. So it's just the final amount. That's all it is. Yes, Kristen?
What is I equals PRT?
I equals PRT is another formula. And it's a portion of the formula right you see right here, right? This is the interest portion. If you're only looking for interest, you can calculate just this portion. I'll show you how to do it on this problem because this is a good example of it. If you're actually asked to find the total amount, then you could add the original principal to it. Yeah. So let me show you, trying to think, does your book show I equal PRT somewhere? It might.
I don't know.
You just remember it. Yeah, let me show you how to use that formula, but let me show it to you within the context of what we're looking on this problem because it'll answer it. So A is actually going to be the amount that they actually are going to pay back to the company that they borrowed from. That's what they're going to do. So if you take a look at this, the P is the $320,000. And then what is R? Yeah, it's 0.135. So we have to take that percentage and we have to turn it back into a number. The way we do that is by moving the decimal 2 to the left. That's what we actually talked about earlier in this particular lesson, is that dividing by 100 is equivalent to talking about percents, moving decimals 2 to the left. And then this one says I need time, and the period of time is 18 months. That is 1.5 years. So to answer your question, Kristen, there's 2 pieces right here. This second piece is the interest. The first piece is the original principal. Now, on this particular question, we really only need to answer the interest question, so we really only need that portion of it. If you weren't sure about what to do with it and you just did the whole problem, at the end, well, let's do this part of it first, and then I'll talk about what happened at the end. So what do you get when you take 320,000 times 0.135 times 1.5? Did you get a value, Morgan?
384,800.
Did you add the 322 at from the very beginning still?
Yeah.
Okay,
The
so
320.
before that you got 64 here, and then this was the 320. Okay. So this is the 384. Does that look right to you? Okay.
Yeah.
All right. Whoops, that's too many zeros. Got an extra 4 going on too. All right, let's fix that. All right, so here is the total amount of money, the $384,800. This is how much they owe back. Right? They borrowed $320,000. They owe back $384,800. Okay? The amount that was interest was the extra above the 320. And in the formula, that was this piece right here, the $64,800. So the interest, which is actually all this particular question asked about, was $64,800. That's a lot of money, isn't it?
Mm-hmm.
Yeah, it is.
Is like interest really that much?
If you were talking about a 13.5% interest rate, that's a very high interest rate.
Yeah, that's what I thought.
That's huge, yeah. We don't see interest rates like that in our society right now on typical things unless you've got horrendous credit. You might see a car loan or something written like that. You will see rates like that on things like credit cards or store loans. You know, like if you do a Victoria's Secret card or a Lowe's card or something, like, you might see an interest rate like that on that kind of a card too. So yeah, if you borrowed that much money, it adds up, and it's a lot. It is quite expensive. Car loans and house loans are usually much lower. House loans right now, don't quote me for sure, but it's somewhere between 3 and 5%. That's what it's sort of been at for quite a while. So that's a lot less than 13.5. They are relatively low, yes. People keep refinancing because if they're low. I have no idea what car loans are at because we haven't had a car loan in quite some time, so I'm not sure. All right, Johnny and Carolyn have 3 savings plans, which accumulated to the following interest for 1 year. They have a passbook account that made $53.90 on a principal of $980. They have a CD that made $55.20 on a principal of $600. And they have a money market that made $158.40 on a principal of $1,200. The question that's asked is which account paid the best annual interest rate for 1 year? Now, there's really nothing special about this one being an interest problem. This is actually something we can do with proportions. But because it's talking about it in terms of principal and interest, it's not something you may have been able to deal with because you weren't sure what the language was before we talked today. Or maybe you hadn't seen it in a while if you had seen it before. So the first one that we're going to do is we're going to take a look at what the interest rate is on this particular account. This is just finding a percentage. So we're looking at a proportion, just like we were looking at proportions last time, of something out of 100, and we're trying to find out what that value is out of 100. That's the percent rate. So on the first account, the principal, the original amount was the $980, so that one goes on the bottom. And that's a terrible looking 9. And we make $53.90. That's the interest. So the $53.90 is the interest amount, and then the X is the interest rate. Okay? The $980 is the original principal amount, and the 100 is the original 100% of the investment. So we can cross multiply this, right? We would have 980 X equals 5390, 5,390. What do we get for X? Oh, we could have used R, I guess, since we were talking about these before. What do we get? 5.5, and this is a percent, right, Shayna? Yeah, so we have 5.5%. So this is a passbook account. It's kind of like a savings account. So this is investment number 1. We can do the same thing for investments 2 and 3, right? So why don't you guys do investments 2 and 3 on your own, and then I will let you guys tell me what you got, and we will make sure everybody's on the same page. The process, the setup is exactly the same as the one we just did. What interest rate did we get on number 2? 9.2%. Good. That is correct. What is the interest rate you get on number 3? 13.2%. Now, after all that work, you have to make sure you answer the question. The question was which account paid the best annual interest rate for the 1 year? Yeah, the triple one, right? The money market. So the answer is that the money market did. Okay, any questions on that one? Yes, Shelby.
The test and the homework, would you prefer we do a proportion, or could we plug the numbers into the formula and solve for R?
You could plug them into the formula to solve for R. The formula you would be using is that I equal PRT formula. You could do that. That would be okay. Yeah, either way should be fine. Okay. We're going to do another one that does not look like it's an interest problem, but it is akin to an interest problem. It's equivalent to an interest problem. It says the following. If a publishing company signed an agreement to allow a textbook with a first edition of 500 pages to expand over several editions to 1,000 pages, and the book is growing at approximately 10% in the number of pages over each edition, how many editions could be published before it reached the contractual limit? So do you understand what it's talking about to start with? We have a 500-page book the first time it's printed. The second time it's printed, it's going to be 10% bigger. Okay, it's going to grow by 10%. Okay? That's a pretty easy one to calculate, but then that value will grow by 10% for the third edition, and then 10% more for the fourth edition, and so on. Now 10% is 10% of the current size of the book, so that will change. So if we take a look at this from the perspective of what we were doing with our formulas over here, this is like the simple interest problems right here. I'm sorry, compound interest problems right here. Get the right one here. What we're actually doing, I'm sorry, because we're doing it on multiple accounts. What we're doing is we're taking the original size of the book, that's the 1, like 1 is 100%. And this interest rate is the amount that it's growing by, that's our 10%. Okay? And then we're going to do it multiple times. So let me show you how this works out. So let's do it sort of in a table setup without the formulas, and then I'm going to show you where the formulas are coming into play. So here's our book. Here's our first edition of our book. It is 500 pages. That already is a large book, right? And then it's supposed to grow by 10%. So what is 10% of 500? That's 50 pages. So the second edition of my book will be 550 pages. And then what's the 10% amount for that? That one's 55. So the third edition of the book is what? 605 pages, right. And then I need 5% or 10% of that, and things start getting a little bit wonky. What do you get on that one? That's actually 60.5, so we're going to round. We recognize that as we round that that's going to make things off a little bit probably in the end. But we're talking about a whole number of pages, right? You can't add half of a sheet of paper to a book. It doesn't work like that. You could only print on half the sheet potentially, but you can't add half a page. So we've got our fourth edition of our book, which is actually how many pages? Ooh, that's not a good number, is it? 666 pages. What would 10% of that book size be? 67, right? Good. And then our fifth edition? What's the 666 plus 67? 7 what? 733. 10% of that? 73. What's my sixth edition going to be? 806. Did I hear that right? Okay. And 10% of that is 81. We're getting close to that 1,000-page limit, right? What's that one? 887. What's 10% of that? 80. Did I hear 89? All right, I realize I'm just moving this into a way that's sort of on top of my own text, but I need more space. So you already wrote it down. What's the 887 plus the 89? 976. And 10% of that one would be 98. And if we were allowed to do a 9th edition, it would have how many pages? 1,700 what? That's not right. 1,074 pages. Okay, so it actually says the max, it says the expand over several editions to 1,000 pages. The book is growing at 10%, the number of pages of each edition. How many editions could be published before it reached the limit? And the answer is 8. They won't keep publishing it after 1,000 pages is what it says, so it can reach 8 editions. Here's the connection I want you to see to what we did. This is actually taking the original 500 pages, and while you guys did 10% every time, what you could have done is you could have actually just taken the value times 1.1. This 10 right here is the 10%. This one right here is the 100%. So if you had taken 500 times 1.1, what would you get? 550, which is the first re-editioned book, right, is the second edition of the book. And so instead of figuring out what 10% was every time and then adding it back to the original value, what you could have done is you could have actually multiplied every time the previous value by 1.1, which is actually taking a two-step process of finding a value and adding it into a one-step process of simply multiplication. And you're doing it multiple times. So when we did this to our 8th edition of our book, this is actually what we did. We did 1.1 times 1.1 times 1.1 8 times. And put in your calculator for me, tell me, what do you get when you do 500